Before I can answer this question, I need to look at what the graphs will look like for 3 simple containers. First, I'm going to start with a container with parallel sides. Let's say after 1 second the water level is here. I can plot this water level on the graph like this after 1 second. After 2 seconds the water level will be here. After double the time, the container has double the depth, and I can plot that here. After 3 seconds, it will look like this, and I can plot that here. Now I can join the points to give me a straight line graph. Because the container has parallel sides, it fills at a constant rate. This is the second type of container. After 1 second, the water level will be here, and I can plot this on the graph. Because the container gets wider, after 2 seconds, the depth won't be double because there's more room to fill here. I can plot this like this. Because the container's got wider still, the added depth won't be as much as in the previous second. I can plot that like this. After 4 seconds, the depth would be here, and I can plot that on the graph. I can join these points up, and I get a curved graph. Because the container is narrower at the bottom than at the top, you can see that for each second, the added depth decreases. The graph looks like this. Here's the third type of container. After 1 second, the water level could be here. After 2 seconds, the added depth has increased because the container has got narrower. That's here. After 3 seconds, the added depth has increased again because the container's got narrower still. That's plotted here. And after 4 seconds, it's added even more depth, and that's here. I can join these to produce a different type of curved graph. Because the container starts wider at the bottom and gets narrower at the top, with every second, the added depth increases, and we get this curved graph. Now that we understand about the different types of containers, it's fairly straightforward to do this question. We can see that this one here looks like the container we've just dealt with, so it matches with this curved graph here. So we have B and R. This one also looks like one of the containers we've just looked at, and this matches this curved graph here. So we have C and P. In this container, it will fill at a constant rate in this section, and then a slower constant rate in this section because the container is wider. This matches this graph, which is only made from straight lines. So we have D and Q. Finally, A must match S, but I want to check it before I write that down. It should fill at a constant rate for the first part, so the graph should have a straight line for the first part. Then it will have a curve for the second part, like this here. So we have A and S. Now I've matched all the containers to the graphs.